Alright, problem number 3. In the game, Cover It Up, you roll 2 standard 6-sided dice, and then you add up the score, or add up the 2 numbers that come up. And you use that sum to cover up numbers on the game board, shown down here. So for example, if you roll a 5 and a 3, that makes 8, and you can either cover the 8, or you can cover the 1 and the 7, or the 2 and the 6, or the 3 and the 5. And the question is, what's the probability of being able to cover the 9 on the first roll of the 2 dice? Alright. Well, let's refresh our memory. Probability on probability. Probability, it's just equal to the number of desired outcomes, okay, over the total number of outcomes. Alright, so we need to figure out these two, the numerator and the denominator, in order to figure out what the probability is. So let's first of all take a look at the total number of ways that the dice could come up. And that's not too bad. So we have 6 sides, so the first dice could come up a 1 or a 2 or a 3 or a 4 or a 5 or a 6. And the second dice could come up 1, 2, 3, 4, 5, or 6, right? So essentially we have a 6 by 6 matrix here, and we could figure up all of the different ways that the 2 dice could come up, right? And so you can see that it's just going to be 6 times 6 is equal to 36. So that's the that's equal to the total number of outcomes. Right? Right? That's just the denominator here. So the denominator is 36. Alright, so let's figure out how many of those rolls would enable us to cover the 9. Well, you know, if we roll a 9, we can cover the 9, right? So if we roll let's just mark those out. So if we roll a 6 and a 3, if we roll a 5 and a 4, if we roll a 4 and a 5, and if we roll a 3 and a 6, that would give us 9. But we could also cover the 9 if we roll a 10 or 11 or a 12, right? Because if we got, say, 12, we could cover the 9 and the 3. And so we'd still be able to cover the 9. So really this whole corner gives us the ability to cover the 9. So if it's not already covered, which we know it's not already covered because you know, we're just on the first roll. Okay, so let's take a look at that. So we have so these 4 give us a sum of 9, right? The 6 and the 3, the 4 and the 5, the 5 and the 4, and the 4 and the 3 and the 6. Okay, so we could also cover the 9 with a 6 and a 4, or a 5 and a 5, right? Or a 6 or a 4 and a 6. Okay, and then we could also cover it if we rolled an 11, which would be basically a 6 and a 5, or a 5 and a 6, right? And we could also cover it if we roll a 12, which is a 6 and a 6. Okay, so I could list those all out. So if we roll a 12, that would be a 6 and a 6, right? If we rolled an 11, that would be a 6 and a 5, oops, or a 5 and a 6. Okay, let me scroll down a little. We could roll a 10, which would be what? That'd be a 6 and a 4, or a 5 and a 5, or a 4 and a 6. And then a 9, we'd have 4 possibilities for a 9, which would be a 6 and a 3, a 5 and a 4, a 4 and a 5, and a 6. Okay, so we have 10 ways of being able to cover up the 9 out of 36 total possible outcomes. So that's 10/36, or if we reduce that down, we get 5/18. Okay, so that's our answer. Now some of you may be thinking, well, it doesn't matter the order of the rolls. And you're right, it doesn't matter. It doesn't matter which one comes up as 6 and which comes up as 5, because you're adding them together, and addition is commutative, so it doesn't matter the order. But we have to be consistent, okay? If we calculate the total number of outcomes in this way, you know, we took 6 times 6, then so here we're counting say a 3 and a 1 as being different as a 1 and a 3. Okay, so if order matters in when we count the number, you know, when we count the number of total outcomes, then we have to order has to matter in the numerator as well, the desired outcomes. Okay, so that's why I listed both the 6 and the 5 and the 5 and the 6. Okay, even though they both come up to 11 and they're commutative, they I just want to be consistent when I calculate the numerator and the denominator of the probability. All right, so if order mattered when you calculated the denominator, then order has to matter when you calculate the numerator as well. There you go.